This is the answer we are heading towards. 2.16 divided by 0.007 is 308.571428 recurring. That repeating bar is not decoration, it is the pattern we must earn carefully. But one small place value slip can change everything. Missing the 0 gives a completely different answer. Scaling only one side gives a different question. Using a mismatched scale gives a different answer again. So we are going to make place value visible. Here is 2.16. There is a hidden thousandths place at the end, and when the 0 appears, the value has not changed. 2.16 and 2.160 are the same number. The 0 only makes the thousandths column visible. Now look at both numbers together. 2.160 and 0.007. If we scale both numbers. Both numbers move by 1,000. 2.160 becomes 2,160. 0.007 becomes 7. Because both numbers have moved together, the answer stays the same. Now the division is 2,160 divided by 7. 7 tries the first digit, 2. It does not fit, so the first quotient digit is 0. That 2 is not thrown away. It becomes the small carried digit beside the next digit. Now the carried 2 joins the 1, making 21. 7 fits into 21 3 times. The 3 rises into the quotient line. Now we reach the 6. 7 does not fit into 6, so the tens place needs a 0. That 0 matters. The 6 is carried into the next place, ready to become 60. This is the rhythm of the whole lesson. Scale, carry, repeat. 3 calm moves, and the calculation becomes controlled. Now for a quick win, 6.4 divided by 0.2. The tempting mistake is to change 0.2 into 2, but leave 6.4 alone. That changes the question, so we reject it. Instead, we scale both numbers by 10. 6.4 becomes 64. 0.2 becomes 2. Same scale, same answer. Now we divide 64 by 2. 2 fits into 6 3 times. The 3 settles above the 6. 2 fits into 4 2 times. The 2 settles above the 4. So the answer is 32. And that answer makes sense. 0.2 is a small group. So many groups can fit inside 6.4. 32 is not a surprise. It is exactly what the scale has revealed. Now we build the carry engine with place value counters. The division is 732 divided by 3. First the hundreds appear, then the tens appear, then the ones appear. Before we share them, we check what each counter means. 1 purple counter is worth 10 blue counters. The 10 blue counters stack neatly, so we can see the exchange clearly. Now 1 blue counter is worth 10 green counters. The 10 green counters stack in the same calm way, so the exchange rule is ready. The 3 group lanes appear. We share the 700s into 3 groups. Each group receives 200s. 100 is left over. That leftover 100 does not disappear. It becomes 10 tens. Those 10 tens join the 3 tens already there. Now there are 13 tens. We share 13 tens into 3 groups. Each group receives 4 tens. 1 10 is left over. Now the same move happens again. That leftover 10 becomes 10 ones. The 10 ones join the 2 ones already there. Now there are 12 ones. We share 12 ones into 3 groups. Each group receives 4 ones. So 732 divided by 3 is 244. That is the carry engine. A remainder moves into the next place and becomes part of the next chunk. Now let us catch a common trap. 75 divided by 2. The times table for 2 appears on its own. For 7, we scan carefully. 2 times 1, 2 times 2, 2 times 3. 2 times 4 is 8, and that is too far. So we use 2 times 3, which gives 6. 2 fits into 7 3 times, with 1 left over. The 3 rises into the quotient line. The remainder 1 sits at the top left of the 5. Now the active chunk is 15. We scan the 2 times table again. 2 times 7 gives 14. 2 times 8 gives 16. And that is too far. so 2 fits into 15 7 times, with 1 left over. The 7 rises into the quotient line. Now there are no whole number digits left, so we open the decimal place. The decimal point appears on the division bar, and a 0 opens the tenths column. The remainder one joins that 0, making 10. 2 fits into 10 5 times. The 5 rises after the decimal point, so 75 divided by 2 is 37.5. The remainder did not become the next digit. It moved into the next place. Now watch what happens when a remainder returns. 10 divided by 3. 3 tries the first digit. 1. It does not fit. So a 0 goes above that first place. The 1 is carried to the next digit, where it joins the 0. Now the active chunk is 10. 3 fits into 10 3 times, with 1 left over. The 3 rises into the quotient line. Now we open the decimal place. A decimal point appears on the dividend, and the matching decimal point rises onto the quotient line. A new 0 opens the next place. The remainder one joins that 0. The active chunk is 10 again, so the next digit must be 3 again, and the remainder is 1 again. We ask the question, and the pattern answers it. The same remainder gives the same chunk. The same chunk gives the same digit, so 10 divided by 3 is 3.3 recurring. Now the divisor becomes tiny. 0.71 divided by 0.002. The divisor reaches the thousandths place, so the dividend must show that place too. 0.71 becomes 0.710. The value is the same, but the place value is clearer. Now both numbers scale by 1000. 0.710 becomes 710. 0.002 becomes 2. So we divide 710 by 2. 2 fits into 7 3 times. With 1 left over, that remainder joins the 1, making 11. 2 fits into 11 5 times with 1 left over. That remainder joins the 0, making 10. 2 fits into 10 5 times. So the answer is 355. A tiny divisor creates many groups, so a large answer is completely sensible. Now we return to the main problem. 2.16 divided by 0.007. First, make the thousandths place visible. 2.16 becomes 2.160. Then scale both numbers by 1000. The problem becomes 2160 divided by 7. Now we work digit by digit. 7 tries 2. It does not fit. So 0 goes above the 2. The 2 carries to the next digit. Now 21 is active. 7 fits into 21 3 times. The 3 rises above the 1. Now 7 tries 6. It does not fit. So a 0 goes above the 6. The 6 carries to the next digit. Now 60 is active. 7 fits into 68 times. With 4 left over, the 8 rises into the 1's place. The whole number part is now 308, but the calculation is not finished. There is still a remainder, so we open the decimal place, the decimal point appears, and a new 0 opens the next column. The remainder 4 joins that 0, making 40. 7 fits into 45 times, with 5 left over. The 5 rises after the decimal point. The remainder 5 joins the next 0, making 50. 7 fits into 57 times, with 1 left over. The remainder 1 joins the next 0, making 10. 7 fits into 10 one time, with 3 left over. The remainder 3 joins the next 0, making 30. 7 fits into 34 times, with 2 left over. The remainder 2 joins the next 0, making 20. 7 fits into 22 times, with 6 left over. The remainder 6 joins the next 0, making 60. 7 fits into 68 times, with 4 left over. And now, the remainder 4 has returned. That means the repeat has begun again. The repeating block is 5, 7, 1, 4, 2, 8. So the final answer is 308.571428, recurring. Now we pull back and keep the whole system clear. First, scale both numbers. Second, carry remainders into the next place. Third, when the same remainder returns, the repeat starts. That is the quiet power of this method. It keeps place value honest. It protects the zeros. And it shows exactly why the recurring block belongs where it is.